Okay, ladies and gentlemen, I have up here an equation. And this equation has fractions in it. So it's a rational equation. And our goal is to solve it for x, to get x isolated. But if you look with this equation, it's very different. We have x's in the denominators and not in the numerators. And that causes an extra problem. Because remember, in algebra, a variable, a letter, is used to represent a number. And if your variable's in the denominator, then you have to be careful that your denominator of your fraction never becomes a 0. So when we're solving rational equations and the variables are in the denominator, before they tell you to solve for x, they're going to say state the restrictions. Restrictions means tell me up front what number makes the denominator equal to 0. What value is going to make the fraction undefined? So here we go. I have 3 different denominators, so I got to get a restriction for each one. Each of these denominators has a variable, so there is going to be a number I could put in this spot that's going to make this denominator equal to 0. Now, some of you can do this in your head, that's great, and others you need to do the paper trail. So what number do you subtract 3 from would make 0? If you said 3, you're correct. If you couldn't think of that in your head, the rule is to state the restrictions. Take your denominator, set it equal to 0, and solve. We have a simple linear equation here, x equals 3. So that's our first restriction. Okay, go to our next denominator. X plus 3. What number do I add? What number do I put here and add 3 to that will make a 0? If you said -3, you're correct. But to prove it to you, again, restriction means take your denominator, set it equal to 0. I'll subtract 3. I'll get x equals -3. So now I have 2 restrictions, but I'm not done. My third denominator is x squared minus 9. Now it's got a square, which tells you there's not one number that will make this denominator equal 0. There will be 2. Again, if you can't think of the 2 numbers that you put here and square and subtract 9 to make 0, the rule is to state the restrictions, take your denominator, set it equal to 0. Now you've made a quadratic equation. What's the quickest way to solve this quadratic equation? Well, when you have a squared term and a constant, the square root method is quick. So I'll add 9, I'll move my constant. So I isolated my square. I square root both sides. Squares and square roots cancel out. When I square root, I always have 2 solutions, and the square root of 9 is 3. Now everybody look, do we really have 4 different restrictions? No, because this says x is plus or minus 3, which I have here, plus 3 and minus 3. So you would answer the question when it says state the restrictions. You would say the restrictions on this equation is x is 3, x is -3. Or you could write it as plus or minus 3. What you're doing is you're coming out in front and telling me, Ms. Black, when I solve this equation, these 2 numbers cannot be the answer for x. Because if these are the answers for x, they will make the denominator of the fraction become a 0. And if the denominator of a fraction becomes a 0, 1 divided by 0 doesn't exist. I want to be able to balance this equation. All right, now we're going to do the solving part. We know to solve a rational equation, the first goal is to get rid of the fractions. This is not a proportion, so we need our LCD. So in our denominator, we have an x minus 3. We have an x plus 3, and we have an x squared minus 9. Now I'm asking you to pull skills I've already previously taught you. To find the least common denominator, all your denominators have to be in lowest factored form. X minus 3 is as low as it can go, it's prime. X plus 3 is as low as it can go, it's prime. But x squared minus 9 is not as low as it can go. If I use difference of perfect squares, I would get x plus 3 and x minus 3. So now to find the least common denominator, I want the most of every prime piece. 1x minus 3, no x minus 3's, 1x minus 3. So I need 1x minus 3. No x plus 3's, 1x plus 3, 1x plus 3. I need 1x plus 3. So there is my LCD, my least common denominator. If you don't remember that skill, then you're really going to have to go back to your modules and review that. Now, what do? We take that least common denominator and we multiply it to every fraction. So I'm going to put parentheses, and I'm going to put these all in the numerator. All right. What we know about is if this is connected by multiplication and this bar means division, we're going to divide out what's the same. An x minus 3 and an x minus 3 divides out. That leaves us with 1 times x plus 3, which is just x plus 3. All right, I'm going to bring down the plus sign. In this fraction, x plus 3 and x plus 3 are the same terms. They divide out. We're left with 1 times x minus 3, which is x minus 3. Bring down the equals. In the third fraction, this denominator is not x squared minus 9 anymore because you factored it. Will the x plus 3 and x plus 3 divide out? The x minus 3 and the x minus 3 divide out? You're just left with 10. You now have a simple linear equation. Here is the wall. I'm going to collect like terms. X and x is 2x. Positive 3 and negative 3 cancel out. If 2x equals 10, I'll divide by 2. X is 5. Now, the great thing is I don't really need to go check this answer to see if it works. I just got to make sure this answer was not the restriction. If this answer is the restriction, then it can't work. Because these numbers right here, 3 and negative 3, are saying if x is 3 and x is negative 3, these fractions become undefined, which means I can't check because I can't perform the operation. X is 5. That's not the restriction. That means that is the correct solution. Okay, see you in the next module.